Welcome to another video. So you're being told to solve for the value of x in this exponential amazing equation. So you're told to solve for the value of x in 1 raised to x is equals to 3. So I'm going to take you through step by step up to the final solution, where we're going to get the value of x. So if you're watching us for the first time, so kindly remember to subscribe, like, share, turn your notification on, so that in case I drop a video, you'll be the first one to watch. I also have a playlist, you can check it out. It has amazing content. So let us dive into the video. So on the solution part, so this typical equation, I'll start by solving it using the Euler identity. That is what's gonna help me to solve it. And the identity is saying that if you have an exponential raised to power pi multiplied by I plus 1, then that is equals to 0. You realize we're going to make I the subject, and then we're going to compare it with 1 raised to x. So the next stage, I'm going to take this positive 1 on the other side so that I have, so that I'm going to have negative of 1. You realize here my 1 is positive, but at this stage my 1 is negative, so I'm going to make it to be a positive by multiplying it by a square function. So I'm going to multiply both sides by a square function of n, so that at this stage I'm going to separate. You realize that when I square a negative number, I'm going to get a positive number. So on my left hand side, I'm going to have exponential raised to power I, which is an imaginary number, multiplied by 2n. I'm going to open the bracket, should be equals to negative of 1 squared, then outside I can let it to be n. Of course, you're able to see clearly that on my left hand side I'll have exponential pi I multiplied by 2n is equals to, of course, when you square a negative number, it is very clear to see that it is 1 raised to power n. But of course, 1 raised to power n, any number raised to power n, of course, it's gonna give you just 1. So you are able to see that if this is 1, then I'm gonna replace it here on my left hand side. So it is true to say that exponential raised to power I, which is an imaginary number, multiplied by 2n is the same as 1. So I'm going to replace all this here because this is equals to 1. So I'm going to have exponential raised to power I 2n multiplied by x should be equals to 3, because the whole of this is equals to 1. and 1 can be written as 1 raised to power n, which of course is equals to 1 raised to power x. So of course that is what I have. Next stage, I'm going to open the bracket using exponential raised to power pi I 2n x. Of course, when you multiply the powers, the bracket gonna go is equals to 3. So it looks nice once again. But for me to remove the exponential power, then this is what I'm gonna do. So let me remind you to take this opportunity to subscribe, guys, like, share, comment with an alternative approach, like the video too. So I'm gonna introduce the natural log on both sides as natural log of exponential raised to power I 2n multiplied by x is equals to the natural log of 3. So it is now clear to see. And also you need to remember that when you have a natural log of an exponential function x, this is obvious equals to x. So when I apply that on my left hand side, I'm gonna get pi I 2n x is equals to natural log of 3. I hope you're able to see it clearly using this identity. So while at this stage, for me to get the value of x, remember x is what I have or what I want, I'm going to divide all through by pi I 2n pi I 2n, so that when I cancel this side, of course I'm going to get x is equals to the natural log of 3 divided by, so I'm going to start by 2n I multiply by pi, which is, so that is what we get as our value of x. So that means we have come to the end of our solution. Kindly, before you leave, remember to like the video, subscribe, like, share, leave a comment. You also have an amazing playlist. You can check out the video on exponential equation, Olympiad equation, and any other maths problem. So until we meet again in the next video, bye for now.